normally it's like the equivalent of this would be 3x squared minus 5x minus 4, right?
But it's not.
But it's not. But even still, when we do the quadratic formula, Ellie, we don't use x anyway. We use 3 as a, negative 5 is b. So you would never plug that in anyway. When we do the quadratic formula with an x, you're doing, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This one is just going to be the cosine of theta equals that. So,
Wait, it's going to be...
so we're still just going to say a is 3, b is negative 5, c is negative 4. We're still going to do the quadratic formula, so the opposite of b is 5 plus or minus the square root. What's b squared? I never write in negative 5 squared because people try to type that into their calculators and they do it wrong. So I always square that b in my head. Minus 4ac. And what's 2a? I usually do this in my head too. 6. So when we simplify this, 5 plus or minus the square root of, oh boy, 48, 58, 68, 73. Square root of 73. All over 2a. I don't trust myself. 25 minus 4 times 3 times negative 4. Okay, so that's what the cosine of theta equals. So I'm just going to type in the 5 plus root 73 version. 5 plus root 73 all over 6. That gives me that answer. 2.25733,958. So if the cosine equals that, is that a number that comes from our typical critical angles? That's not on our table, right? So this is just calculator. We will do so let me write this more clearly. Cosine of theta equals that 2.25733,958 number. On my calculator, I'm just going to do inverse cosine of that. Should I be in degrees and radians? Go back up, look at the original question. Degrees. So I'm constantly flipping back and forth. So inverse cosine of that answer. And inverse cosine is going to give me something in quadrant 1 or 2.
Wait,
You what?
why are you taking the inverse cosine of that?
Because the quadratic formula is normally x equals that, and this is cosine theta equals that. So when I'm trying to solve for theta, I do inverse cosine of that 2.25 number. You follow?
Yeah, I got that.
So on my calculator, it's just going to give me one answer. And again, inverse cosine is either in quadrants 1 or 2. So it's going to be something between 0 and 180 that my calculator is going to give me. Uh-oh. Or, why is it giving me nothing? Because it's over 1. So this particular branch, the 5 plus the square root of 73 branch, has no solutions. I didn't realize that until that popped up in my calculator. Some of you might have realized that that's not going to work. I didn't, but my calculator gave me an error, and then, oh yeah, that's over 1, so it wouldn't work. And then, so I'm also going to do 5 minus the square root of 73 over 6, and that's negative 0.5906672909. So that was all a bust. It won't always be, but it was there. Cosine theta equals negative 0.5906672909. And so I'm going to do inverse cosine of that. Inverse cosine of that number. Just go up and drag it down. Again, it's going to give me some angle in quadrants 1 or 2. Will it be in quadrant 1 or 2? If cosine is a negative number, it is going to be in the second quadrant. So the first, they're giving me 100, let's round to the nearest degree to keep our life simple, 126 degrees. So theta equals 126 degrees. Now, the calculator only gives you the one answer between 0 and 360. You have to find the other one on your own, because there's 2 quadrants where cosine is negative. So they gave us, all students take calculus, There's going to be an answer that comes from the second quadrant. That's the 126 that they gave me. Because between 0 and 360, it's going to, cosine is negative in 2 of the quadrants as I wrap around, just like everything else. So from that 126, and this is the trickiest case, I guess, because we have to figure out our own reference angle. What is that reference angle? Well, we're going to go to the nearest degree. 54 degrees, right? So to get from 126 to 180, that's a 54 degree reference angle. And so to get to my third quadrant answer, I'm going to go 54 degrees past 180. 180 plus 54 is 234. And those are my two answers. So we're still doing the same stuff. Well, that always could have happened over the past 3 days. If you ever are doing an inverse cosine of a negative number, it's always going to give you the second quadrant. It doesn't happen with inverse sines and tangents because they'll give us a positive angle or a negative angle, but whatever that number is the reference angle. So inverse sines and tangents we never bothered with. Inverse cosines, if it's an inverse cosine of a positive, it's going to give you the first quadrant, which is the reference angle, so you don't have to think about it. So when you're doing inverse cosine of a negative, that's the only time that you'll have to think about what your reference angle is on your own. But that has nothing to do with the fact that this is a quadratic formula. That could have happened and has happened, I think, anyway. Okay? All right. Brock, you may go. This one, again, being a tangent square, you have a tangent squared term, you have a tangent term. So it's a quadratic, but you would probably subtract the 4 tan over, hopefully. Get it into your typical equal to 0 format. Thanks, you too. If you do these on a test, you're not going to know if it's a factoring type or a quadratic formula type. So you may always elect to try to factor first if you really don't like the quadratic formula, or if you love the quadratic formula, you might just always do that. There's no real dictation of what you have to do other than if it's not factorable, you have to know how to do this method. And this one's not going to be factorable, so we're going to say that the tangent of theta equals, what's negative b? 4 plus or minus the square root. What's b squared? Nope, that's a squared. 16 is b squared. Minus 4, a is 5, c is negative 2. All over 2a is 10. So that is 4 plus or minus the square root of 56. What? What's the problem? Okay. Well, if I were you, I would do it too. I just did 20 and 2. 20 times 2 is 40. The double negative is a plus. 16 plus 40 is 56. You be my auditor, Allie. Okay. And I don't really care about breaking down into simplest radical form. I'm just going to come up with a 2 decimals. So the tangent of theta could equal, and I'm going to type in, now what would be impressive is if I could do 4 plus the square root of 56 divided by 10 in my head and get that, which I can't. But that's the 4 plus version. And then also I'm going to have to solve the 4 minus root 56 version. All over 10. Negative 0.34833147774. And then this is where my inverse tangents are just going to come in. Inverse tangent will always be between negative pi over 2 and positive pi over 2. This one, is this going to give me the first quadrant answer or the fourth quadrant answer? If tangent is a positive number. Is that the first quadrant or the fourth quadrant? All students take calculus first. So we should expect something that's between, and we're still in degrees, thank God, between 0 and 90. So if I do inverse tangent of, what's it, the 1.14 number, so I went up and I'm just going to grab that, and let's go to the nearest degree, 49 degrees. So theta equals 49 degrees. Now going back to the full rotation between 0 and 360, what other quadrant is tangent positive in? The third. And our reference angle is that 49. Yes? So we have our 49 degree answer, and we're also going to have a 180 plus the 49 degree answer. 180 plus 49 is 229. So those are the two answers that hit the two quadrants where tangent is positive. Then we're going to do inverse tangent where this is negative. Inverse tangent, oh, I deleted it, so I have to go back up and look for that negative 0.3 number. There it is. And this is when tangent is negative, so it's going to give me something in the fourth quadrant, a negative 19 degree angle. That can't be one of my answers. Why not? Right, it has to be, I have to give answers between 0 and 360. So that's going to give me my reference angle of 19 degrees. So when I go around my quadrants and I'm looking for where tangent is negative, I need to grab 19 degree reference angles from the second quadrant and the fourth quadrant. So to get to the second quadrant, I'm going to do 180 and I'm going to back up 19. Yes? 180 minus 19 is 161. And then to get the fourth quadrant one, I'm going to wrap all the way around to 360, and then I'm backing up 19 degrees. So 360 minus 19 is 341. So even though your calculator gives you that, it's not an answer that you can give. But it's not as terrible as the cosine one, because at least it tells us the reference angle. Right? Any questions on that? All right, so just three of these problems for homework. Just do the odds on this worksheet.
It'll be over.
I just don't want a subject where you can't do it.
Yeah.
It is?